we're going to work with central and inscribed angles, some more uh, facts about central and inscribed angles today. And the first one is an inscribed angle is half of a central angle when they intercept the same arc. And I actually don't use this. I tend to just figure it out on my own. But if we look at the example here, find the value of the missing variable in each diagram below, what happens here is that at W here, this is the inscribed angle. And I use the idea of the inscribed angle, which is the measure of the inscribed angle is half the measure of the intercepted arc. So eventually we want to figure out what the central angle is. And all that I say is, well, if 41 is half the measure of arc UV, then to figure out what arc UV equals, we have to double the 41. And when we double the 41, we get 82. And that's the measure of this arc right there. And then the last part is, once we know this arc, it relates to the central angle, which has its vertex at the center. So if UV is 82, then X is also 82, because the measure of the central angle equals the measure of the intercepted arc. Now, the rule that we just looked at is faster, but again, you have to remember that rule. And what that says is, if an inscribed angle is half of a central angle, so this 41 is half of the central angle. And again, 41 times 2 is 82. But you'd have to remember that property, and so there's another way of doing that. If we do use that property, what it says once again is, it says that if we know this value is half of that value. That's what the inscribed angle property number 1 says. And what we get then is that X equals 1/2 of 162. And use decimals, use your calculator to figure that out, but half of 162 is going to be 81 degrees. Again, I look at it from the perspective that this is a central angle. It has its vertex at the center. And here is our intercepted arc, which means that this value is 162. And then it's the measure of this angle. The measure of angle X is half as big as 162. I don't remember that property, honestly. There's another property. An angle inscribed in a semicircle is always 90. And this one is a good one to remember, but I hope that as we apply it doing our practice, that we can remember it, and it's not something that we have to go back and memorize. An inscribed angle in a semicircle is always 90 degrees. So when we look at this here, what we've got is that we've got a diameter from here to here, and this angle here, A, is the inscribed angle that we're looking at. It's not B here, and I need to kind of start over again in terms of my explanation, but the first thing that I look at is defining the fact that this value is a diameter. Goes through the center circle, has the endpoints on each side of the circle. We know 124 degrees for this arc, and how many degrees in a semicircle? Well, there's 180 degrees in a semicircle, so we can say 180 minus 124, and when we look at this, 10 minus 4 is 6, 7 minus 2 is 5, we get 56 degrees. So now that we know that that's 56 degrees, and that's what C degrees is, because again, we did the 124. So here's our 56 degrees, and we want to figure out the missing variables. So we just figured out C. Let's figure out B next. And B is an inscribed angle. And once again, the measure of the inscribed angle is half the measure of this red arc right there. And we figured out what that red arc is. It's going to be half of 56. And again, type it into decimals, type it into your calculator, but half of 56 is 28. So this value here is 28, and we want to find the other angle. And the other angle goes back to this rule, which is an angle inscribed in a semicircle is always 90. And if you think about it here, we've got 180 degrees here. We have 180 degrees there because that's half of the circle. And then the measure of the inscribed angle is half the measure of our intercepted arc, and half of 180 equals 90. And that's our value of A. You didn't necessarily need to do that work if you know the property. Otherwise, we have to figure out the values. Same kind of idea here. And the one thing that we know, as we take a quick look at this one, is that here is the diameter. Again, has endpoints on the circle. It's a chord that has endpoints on the circle, goes through the center of the circle, and we know 60 degrees. But what happens is, if we know that property, we also know that that value right there is 90 degrees. Otherwise, what we have to do is we have to figure that out. Here's half a circle. Half a circle has 180 degrees in it. And again, 1/2 of 180 is 90. So that's that property. That's where that box in the corner came from for the 90 degrees. But what we really want to know is, how big is B? And we can take a closer look at the figures in here. And what we're looking at is we're looking at this triangle. And what we also know about a triangle is that there's 180 degrees in a triangle. So we know 90 degrees. We know 60 degrees, which gives us 150. But there are 180 degrees in the triangle. So 180 minus 150 is going to give us our value of 30 degrees for B. Letter C. And we're still talking about the fact that an angle inscribed in a semicircle is always 90 degrees. And again, if you know that, you don't have to figure it out. Angle M is 90 degrees. So that might be helpful. There's something else that's helpful in here that didn't show up maybe as well on your notes as I would have liked. And that is that this length is the same as that length, which means we're working with an isosceles triangle. And consequently, if LM is congruent to MN, then angle L is also congruent to angle N. And once we know that information, then we can figure out the value here of X, which is ultimately what we're trying to do. What happens is, angle N was given to us. It's 2x minus 5. But because angles opposite congruent sides are congruent, angle L is also 2x minus 5. We figured out early on, either by the property or by using the fact that angle M is inscribed from arc LN, it's 90. And then we're going to get 180 degrees. 180 degrees in that triangle given there. And now we're going to use our algebra skills. We're going to combine like terms. 2x plus 2x is 4x. -5, -5, and 90 is 80. And that equals 180. I'm going to solve. We're going to subtract 80 from both sides. And we end up with 4x equals 100. And divide both sides by 4. And we end up with x equals 25. Third property. The opposite angles inscribed in the quadrilateral are supplementary. Again, this is one that you might need to memorize. But hopefully with our practice, we at least can apply it enough that we can kind of remember without having to sit down and actually memorize. But opposite angles inscribed in a quadrilateral are supplementary. So here, we have a quadrilateral, a four-sided figure that's inside of the circle. And what happens is we want to find, on this particular problem, we want to find the missing variables. We've got two of them. We've got x and we've got y. But what happens is that x and 80 are opposite angles. And our rule says that opposite angles inscribed in, if I can say it again, opposite angles inscribed in a quadrilateral are supplementary. So that means that x plus 80 equals 180. Supplementary means adds to be 180 degrees. And maybe you don't even need to do this math here. So what we end up with is we end up with that x is 100 degrees. Same idea with the other two angles, 71 and y. Well, 71 plus y equals 180. They're opposite angles inscribed in the circle in a quadrilateral. We can subtract 71 from both sides. And 10 minus 1 is 9, and we get 109 degrees. It's nice when we have the numbers, but as we look at our next example, we've got some variables. And on this one, we're still finding the value of the missing variables. But angle B and angle D are opposite angles. So when we set this up, we're going to take the 21x minus 8 plus the 23x plus 12. Those two angles are supplementary. They add to be 180. And if we can get the setup, then we're going to apply our algebra to figure out the rest. 21 plus 23 is 44x. Negative 8 plus 12 is 4 equals 180. We want to figure out what does x equal, so we subtract 4 from both sides. And we end up with 44x equals 176. Divide both sides by 44. $176 divided by 44 is 4. A third type of angle that we will introduce in this lesson is a circumscribed angle. And a circumscribed angle is an angle formed by two tangent lines. So if we look down here in our picture, line AB is a tangent line. Line BC is a tangent line. And in fact, those are, if you want to get technical, are rays. But it's an angle formed by two tangent lines. So this is our circumscribed angle. And then In the diagram below, angle ABC is the circumscribed angle because A, B, and B, C are tangent to circle X at points A and C. And if we can recognize that we're working with the circumscribed angle, what happens is that the measure of a circumscribed angle and a central angle that intersect at these points here, at the points of tangency, they're supplementary. So in other words, they're going to have the same arc when we're dealing with this. And it shows up better when you look at these last two examples here. In the diagrams below, find the value of the missing angle. So now we have the central angle drawn in here at angle O, and I don't want to cover up the 117, but there's the central angle. Here's the circumscribed angle, and what happens with those is that 117, the central angle, plus the circumscribed angle are supplementary. Supplementary being adds to be 180, and we can subtract 117. 10 minus 7 is 3, 7 minus 1 is 6, 63 degrees. On my very last example here, I forgot to put in an X here, but we'll put it in, it's a question mark, you can't see it very well, so we're just going to put that X in there so you can see it as well. And we need to do a little bit more work on this one here, but it kind of uses that rule that we had at the very beginning that said an inscribed angle is half the measure of the central angle. And you don't have to remember that one. You can figure it out because here's the inscribed angle. It has its vertex on the circle. And this measure of the 30 degrees is half the measure of our intersected arc. So 30 is half of 60, which means that if arc CB is 60, then the central angle is also 60. And once we know the measure of the central angle, then we can figure out the circumscribed angle. It is 60 plus X equals 180. One last time, this angle and this angle are supplementary. So if we subtract 60 from both sides, we get X equals 120.